Okay, so solutions. We already talked about the degree is the largest exponent. It provides you something about end behavior and the maximum number of possible solutions. But you know, finding the solutions is one of the things that we need to look at a little bit further. So if you have a graph, then finding the solutions should be fairly straightforward. So what are the solutions to this polynomial over here, the first one? -3, because it crosses. -1. +1. And +4. So sometimes it's just a matter of reading it off. So what are the solutions to this one? -3 again. 0, because it does cross at 0, so that is a solution, and +3. Okay. Well then, if you have the graph going to the, and you have the solutions and you can read them off, then actually writing the equation, that really shouldn't be a problem anymore. And fortunately I still have something on the board there. So if it solves at x is a -3, then what is the, and I need to erase this a little bit so I can squeak, the factor that goes with that indeed is x plus 3, right? Is everybody okay with that? Okay, so if these are the solutions, then the factors here would be x plus 3, x plus 1, x minus 1, and x minus 4. So the first equation in factored form, and today we'll just leave it in factored form mostly, x plus 3, x plus 1, x minus 1, and x minus 4. Okay? How about this one over here? So we have solutions, then the factors will be what? X plus 3, just an x, and x minus 3. Okay, so if it's at 0, the factor is indeed x, so here, and if it's an x, we usually lead off with it. So x, and then it's x plus 3 times x minus 3. Now order doesn't matter at all, right? Okay, so I wouldn't count it wrong if you wrote x plus 3, x minus 3. This just looks better. Okay, now on this one I do want to go on and show you a little bit more. And I could do the same thing on number 1, it just would take longer and I don't have the room for it. So that's the next thing I'm going to do. So yes, you can just spoil these, right? And since this one is a pattern, this one, that's why I'm picking this one. This one's a little easier because we should hopefully see that this is just going to give you x squared minus 9, right? Very similar to what's still like on the board when we had x squared minus 4. It ended up with x plus 2, x minus 2. So you can do this. And then you can go one more step, right? If you write this out all the way, x times x squared is x cubed, and a -9 times x is a -9x. So now it's in polynomial form. Because if you write it as a polynomial, yes. Can you what? Yeah. If it's in polynomial form, then we would only have an addition and subtraction of terms. So this one over here is not really written as a polynomial yet. Okay, so this is a factored polynomial, what I have in the first two. Okay, and then the last one here, that's really what a polynomial is. What it looks like. Now I don't really care, and today you don't have to do this last word, but I want you to see how this is going to end up looking down the line, because it's not going to look like x times x plus 3, x minus 3. Yes? How do I spell polynomial? It's in the title. Yeah? Well, that's neater than I can write it, so that's why I'm saying it that way. Can I move on? Okay. So, and we've already done this a bunch. We just graphed it, and I don't know if you guys have really connected that with the solutions. So if you have factors, then what are the solutions to this? X equals 3 and +10. So does this 2 do anything? Not for the solutions. Now it makes the graph go up faster, but in terms of the actual solutions it is not. Okay, because keep in mind that another word for solution is x-intercept, right? So if you're wondering where is this coming from, well, these are the x-intercepts. That's it. Okay, on this one, what are my solutions here? -1, +10, and 0. Okay, don't forget the 0. We're good? Alright. So how do you find solution if they're not in factored form? Well, one thing that you can try is to factor yourself, right? Okay, so let's start with a quadratic, because that is a polynomial, and we've worked with it a lot. So how would you find the solutions for x squared plus 5x minus 14?
X minus 2 times x plus 10.
Yeah, that is the fastest way, isn't it? Could you have used the quadratic? Sure. Just takes more work. It's possible. Okay, so but factoring here is something that's nice and easy. Yeah? Okay. How about the next one then? That's a cube. Can we factor it? Apparently, since I said that one of the factors is x plus 2 and then, factoring it. The answer is going to be yes, but right now do we have the tools yet to factor that? No, we don't. Alright. So how can I sort of factor this? Well, this is something new that I'm going to do today. I'm going to explain it. I'm going to show you once. Okay, what this is called is synthetic division. And it's a shortcut to long division. Do I really want to show long division? I would prefer today if you just take on faith that what I'm going to show you here works. Okay, and then maybe tomorrow or another day I'll show you the connection to long division, but for today I'm going to do this backwards. Usually I would have shown you first what it is and why it works, but I think on this one it actually works better just to go ahead and do the method. So this is what synthetic division is. X plus 2, if you set that to 0, then the 0 that goes with that, or the solution that goes with it, is a -2, right? Okay. So I'm going to use the -2 over here sort of as the thing that I'm going to try to divide with. And the next thing that I need to pick up is are these coefficients. So an x cubed is a 1, the x squared has a -1, that's a -24, and this is a -36. So the reason this is called a shortcut is because do I do anything with the cubes, the squares, and the x's? No. So we're just looking at the coefficients here. Okay. And then I'm going to go set up my pattern. So I want to make sure that you watch. So it's there. If anybody's still writing, I'll give you a second. But so the pattern starts this way. You drop the 1. Okay, so the 1 just drops. And then we do a -2 times 1 is, and that goes over here. And usually when we have things in columns, it's because we add stuff. Okay, so what's a -1 plus a -2? -3, right? And then we do a -2 times a -3, which is 6. And in columns we usually add stuff. And a -24 plus 6 is -18. And then we're going to multiply again. And a -2 times a -18 is positive 36, right? And a -36 plus 36 is 0. Okay. If you believe that this is a shortcut to division, then this is your remainder. So what does it mean when you have a remainder of 0? Right, so that means that the division sort of worked, right? Okay, so let's just say that the division worked. Okay, it went in evenly, is sometimes what people say, like 8 divided by 4 is 2 without a remainder, so 2 goes in even into 8, right? Okay, so the division worked, however you want to think of that. Okay, so what do these numbers now here, and I need to erase one of them because that looks like it's a -1. So what do these things here represent? So what does the 1 represent, what does the -3 represent, and the -18? Well, sort of keep in mind that I said this is division. Okay, and so what we took this cube with a whole bunch of other junk, and what did I divide it by actually? I divided it by an x plus 2, right? Well, what is x cubed divided by x? X cubed divided by an x is x squared. So guess what this 1 stands for? Yeah, it's got to be an x squared. And then the next one's probably a negative 3x, and then this one is an 18. And that means that I could rewrite the first one this way. It actually could be written as x plus 2 times x squared minus 3x minus 18. Okay? So this synthetic division allowed me to rewrite this first expression, this cube, that didn't look like it was factorable. Okay, with synthetic division I can find 1, negative 3, negative 18. That's the quadratic that I am left with if I took out x plus 2. Okay, so how is this helping me find the rest of the solutions? Because, alright, I started with a cube. I know that one of the solutions is what? From the start, negative 2. Well, I need 2 more solutions, right?
You factor that.
Yeah, you factor this one. How does that one factor? Negative 6 and a positive 3. Okay, so we were able to completely factor a polynomial. And the solutions to this polynomial must be what then? Where did you get a negative 1 from? Negative 2. Okay, I'm sorry, I misunderstood. Negative 2, 6, and negative 3, right? Yes? Okay, well that's it. That's called synthetic division. Which, well, it looks hard, and a lot of people don't like it, and then when I do the quiz on it, you guys are going to say that's one of the easiest problems on there. Because it's just a little shortcut, so you just have to memorize the pattern. And there's a little self-check in here, because if this is going to work, so if x plus 2 is a factor here, this has to happen, okay? This has to be 0. So that's sort of a self-check that you have in here, if you're doing it right or not. So I'm going to do this twice more. Yep. Are we struggling with a little bug? Really? Just get rid of it. You know, step on it, flick it. Alright. Okay. So synthetic division. And today I don't think we're doing anything that is not going to work right. So, but I'm already giving a heads up for tomorrow. So we got to make the coefficients. We have to use the coefficients of the polynomial in order. We need to fill in missing places. We won't deal with that today. And then you start the pattern by dropping the leading coefficient. We're using the 0, not 0. You're using the 0 to multiply, and then if you do it correctly, you should have a remainder of 0. Okay, so how does this one start? Well, that's a 1, that's a 1, right? So the top line is 1, negative 1, negative 9, and 9. If the factor is x minus 3, then the 0 will be what?
3.
X is 3. So I need to use a 3 on the outside over here. Start the pattern by dropping the leading coefficient. So if this had been a 2, I would drop 2, but it's a 1, so drop it, and then start. 3 times 1 is? It's 3. A negative 1 plus 3 is? 2. 3 times 2 is? And a negative 9 plus 6 is? 3 times a negative 3 is? We get 0. Good news. Right? We did something right. So this is the quadratic x squared, bless you, plus 2x minus 3. Does that factor any further?
No.
I think it does. Yeah. Maybe the other way around. X plus 3 and x minus 1. So the whole polynomial could be written this way: x minus 3, x plus 3, and then x minus 1. Yes? So all the solutions will be what? Negative 3, positive 3, and 1. Okay, I'll set up this one, and then I'll give you a chance to do this on your own, and then I will just go ahead and do this in just a second, so you can sort of follow, see if you did it right. So the top line should look like this. I did give you a solution, right? So that's the number you want to use.
We're not worried about the exponents, all we're worried about is coefficient. So you
Yes.
have to do square, that doesn't make so much sense.
Now if this had been an x squared, you would, and it was the largest one, you would start with the x squared.
Okay.
But x squareds we don't have to do that on because we can factor them in, right? Yeah?
Yeah.
Okay, so we already have a way to deal with x squared. So you wouldn't use synthetic division probably on an x squared, at least not in this context. Okay, so I started the problem for you, see if you can finish. I'll give you a little bit of time. And I'm going to hand out in your homework while you read the last little bit. So I finished it. Somebody already said that you get 2 4s, well 2 negative 4s, right?
Yeah.
Okay, if you get a negative 4 more than once, you don't need to list it more than once. If you did, it's fine. So if you wrote negative 4, negative 2, negative 4, it's not wrong. Okay, you just don't have to. And then
You need to put x to 4 squared in brackets.
yes, and then somebody else, yes. So I could rewrite this one as well. It would still be considered in factored form. This could be written as x plus 4 squared times x plus 2. Okay, so that's also correct. So none of that really matters too much in terms of the solutions and all that stuff. It would matter how you graph it, but that's for next year. I don't want to get into that this year. Okay?